Hello all, good evening. Yeah, before starting, do you have any doubts or any things you want to share? Like, am I going speed or slow? Yeah, guys, hope I'm audible.
Yes, sir.
Yeah, thank you. Okay, today we'll start with Snowflake architecture. So, before understanding the Snowflake architecture, first we will understand what are the existing traditional architectures. 1 minute, guys. Okay, first we'll understand the traditional architecture and what are the advantages and disadvantages in traditional architecture, why Snowflake is different from those architectures, and why the Snowflake become popular. These things we'll discuss. In a traditional databases, there are multiple architectures are available. Out of all, two are the main architectures. One is shared disk architecture. One is on a shared disk architecture. Another one is shared nothing architectures. Most of the databases are warehouses belonging to either of these architectures. If you remember during our demo, I shown the Amazon Redshift, Azure Synopsys, Google BigQuery, and Teradata are belonging to any of these architectures. Now we'll understand what is the shared disk architecture. So if you consider this is a one cluster, if you consider this is the one cluster, right? If you consider shared disk architecture as a one cluster, a cluster is nothing but a group of nodes. What is a node? A node is one cluster node, means which having the processing power. Processing power nothing but and CPU and memory, right? That particular node having the CPU and memory. You know, CPU means central processing unit, memory is nothing but RAM, random access memory. These are kind of compute power to do some actions like to load the data or to process the data. So each one is in a one node and a group of nodes we can call as in a cluster. And for the storage purpose, we'll use the disk storages here. Now, in this shared disk architecture, this complete disk is a kind of one disk. It is shared to the multiple nodes. Means disk is shared among the various nodes. As the name suggests, shared disk means disk is a centralized disk. That disk is sharing to various nodes. So consider there's a kind of some data stored over in this centralized disk. Here the data is the disk is a centralized one, and there is some data. And if any request come to load balancer, that request will send to any one of these nodes. After receiving the request, the node started processing like to like it is a kind of some query which need to process the data. This node will take the data from this disk and will process it and send a result back. So the data is centrally located. Each node is sharing to same disk via the one interconnection network, right? Via the one interconnection network, right? Let me clear these things. So, all these nodes are connected to the disk via the one interconnection network. So, what about the share nothing architecture? If you see here, in case of a share nothing architecture, again it is a cluster. A cluster is nothing but a group of node. A node is having the some compute power, which is nothing but CPU and RAM. So, in this, there are the 4 nodes in our diagram, which is a kind of some one cluster. Now, in this diagram, the disk is independently connected to the each node. The disk storage, whatever the storage is independently connected. This, if you consider this is the node 1 connected to disk 1, node 2 connected to the disk 2, node 3 connected to the disk 3, node 4 connected to the disk 4. Means here all nodes are independently connected to a portion of the disk storage. Now, if you consider, again there is a kind of some load balancer. If you consider, there is a kind of some request came to process the data. That request will send to any one of these cluster node. That node will be connected to this disk to process the data. That's why the disk is not shared over here. The disk is not shared over here across the nodes. That's why it's a share nothing architecture. And all these nodes are connected with some network communication. This network communication is only to share the signals, not to the data. In this network connection, data is sharing over the network. Data is transferred over the network. But here data is not transferring because all nodes are independently connected to the separate disk storage. That's why the data is not transferring here. Data is not transferring here. But here the data is transferring, right? So, in case of a shared disk architecture, disk or the data storage layer is a centralized layer where the data is transferred to all the nodes via the one interconnection network. Now, what are the advantages of in case of a shared disk architecture? If you want to add one node, if you want to add one more node, it's very easy to add. In case of a shared disk architecture, if you want to add one more node, it's very easy to add, right? It's very easy because it's simply adding one node to the cluster. Already disk is connected to the interconnection network so that the data is shared through the same network connection. That is the one advantage. What about here? If you want to add a network, if you want to add one more node here, you need to add separate disk. You need to add separate disk. Now, if you see here we said this is a single common disk, means all disks are interconnected again with the same network. All disk storages are connected with one network, means all the data is centralized located. Means here the data is central located, but here data is portion of the data stored in each disk, which means data need to be partitioned in case of a share nothing architecture. Data is need to be partitioned, but here centralized storage, no need to partition the data. Means here there is a portion of data, here portion of data, here portion of data, here portion of data, but here is a common disk, it's a centralized data storage. What is the difference? In case of a centralized data storage, we don't want to partition the data, but in case of a share nothing architecture, we need to process, we need to partition the data. What happens if I add the one more node? I need to add the separate disk storage, and I need to redistribute the data of four disk storage to the out of 5 storage. For example, there is each disk storage having the 1.25 TB of, there are the 4 nodes are there, total 5 TB of data. For example, if I add one more node, total nodes are 5. Out of 5 TB data, each disk storage will be stored for 1 TB data, which means there are the 5 5 disk storages, and there is a 5 TB of data. Out of previously in each disk storage there is a 1.25 TB data. Now that is redistributed to the all five disk storages of 1 TB data, which means that for the redistribution of this data there is a time taking as well as some additional charges are occurred to redistribute the data. So adding node in case of a shared disk is a simple, means it's a easily scalable because of centralized data location. But here it is not easy. It's not easy to scale. Means if you are adding the node, you need to add the disk storage, separate disk storage, and so that you need to redistribute the data, you need to repartition the data. Clear? And let me clear these things. We'll discuss another point. Next one is fault tolerance. Let's assume, and there is a kind of some request came, that requests are processing on each side. Now, due to some problems or due to some disaster issues, one of the node failed. Right? One of the node failed. Whatever the request assigned to this node is easily allocated to another node, and it can be processed. Why? Because the data is centrally located for that particular request. Whatever the request came here, for that particular request, whatever the data required, that come from the same disk storage, which is central located, so that the same request will allocate it to the another network and another node, and so that it will use the same data to process request. So it's a fault tolerance. What about here? For example, if there is a one node failed, before that there is a one request allocated to here, right? Now, whatever the data required for that request available in this disk storage, but if this request allocated to here, the data required for this request is not available in this disk storage. That's why it's not a fault tolerance. For the fault tolerance, which is a good one, shared disk architecture, right? Now let me clear this one, and I will explain another point. And what about the scalability? We said that we can easily add. Means it's a scalable. We can easily add node. But the drawback here, for each and every node, the data is transferring to this network only. Consider you can take the one room. You can consider there is a one room is there. For that room, there is only one door. If there are the 10 people are going and coming, that is a kind of some frequency. If 20 people are 20 people are traveling to the same door, that is a consistency. There is some issue. If 50 people are goes on increasing, right? Again, there is a more crowd is there in the door. In similar way, if more number of clusters are adding, if more number of nodes are adding, the data traveling through this network become the issue that is causes the bottleneck of the network. That is the one issue in case of a shared disk architecture. But in case of a share nothing architecture, there is no bottleneck. Right? There is no bottleneck. If you are adding one node, that is a separate disk, so that there is no bottleneck, because the data in a share nothing architecture is not transferring over the common network. But in case of a shared disk architecture, data is traveling through the common network where there is a bottleneck occurred. So these are the some advantages and disadvantages of the shared disk architecture. Clear? Now we'll move to the Snowflake architecture.
Sir, can you repeat the previous one, the bottleneck architecture?
Yeah,
where
sure.
In the share disk it is going to share, but not in.
Sure. Let me clear and type again.
Sure, sir. Sir, here in shared disk one, if any load is given, that is equally distributed to all the nodes, sir.
Sorry, in
In the shared disk architecture, if any
okay.
load is given, that is equally shared to all the four nodes, sir.
That again depending upon the node size and all. If we are taking the same size of the nodes, that will equally shared. Mainly
Sir,
here,
how the output is going to come if it is going to share equally for the four one? Only one we had the data like.
no. Here the main thing is when we are dealing with any database or the data warehouse, there are the multiple requests coming from the different areas. That requests are connected to the one load balancer. From that load balancer, requests are sending to the according to the nodes. It's not like directly applying the load. It's a kind of applying the request, right? For example, if you consider our data warehouse, for the data warehouse there are the different loads are available. For example, data science team is there, analytical team is there, right? And if I kind of some analysis purpose, there is a different users are there, different users are accessing, and they are sending the some request in the form of queries. That queries connected to that queries first go to the load balancer. From there it will automatically balance the loads to the various nodes. That node will consider that particular one request, that process, by utilizing the data.
Okay, sir. When just now you said if it got it is not taking the load, it is going to transfer to other one.
Yeah, that is load balancer will take. There is a ALB is there, automatic load balancer, network load balancer, types of different load balancers are there. This basically comes into admin point of view, not into our point of view. Just we need to understand the architecture. This is a
Okay.
kind of some automatic load balancer, network load balancer. Different types of load balancer are there, and there is another concept called monitoring. Like it is going to sending a load balancer is sending to the one health check to the each node.
Okay. Okay.
Health check means whether the particular node is live or any issue. If it is the kind of some if you see HTTP protocols, right? If it simply it will send the some kind of some health checks. If it is an up and live, it will get the acknowledgement response, I am okay, right? When it is not getting the response, it consider that is a that particular node is a failed, so that that particular request move to the other location, other node by with help of a load balancer itself only.
Got it, sir.
Yeah,
The last one, you
yeah,
said
yeah.
you okay.
So, for example, for now there are the four nodes here, right? If there are the four request came for all these nodes, data should come from the this common interconnection network. If four more nodes are added, 8 nodes should get the data through this network only. If we add like 100 more, all 100 nodes should get the data through this common interconnection network. Because of this common network, there is a bottleneck occur. Right? For example, if there is only four nodes, each is having the one request, means four requests. There is a four request data is need to travel over here. If there are 100 nodes, 100 request, 100 request related data need to travel over this interconnection network only, because data is traveling through the common network. That's why there is a bottleneck. If you consider here, each is independently connected. Data here is not traveling through the common network, traveling through the independent network. The data required for this request in this node is traveled to this network. Data required for the request which is in this node is comes from this network only, so that there is no bottleneck in case of a share nothing architecture. It's a called as an MPP, massively parallel processing machines. It's a massively parallel processing machine. It's all are simply it's a like a parallel machines, parallel nodes. There is no bottleneck here. Clear?
That means in shared disk architecture, it slowed down, sir.
Yes,
If we
performance
add more
degrades.
and more,
Yes,
it is,
performance degraded.
yes, but here it won't.
It won't happen, but there is a kind of some additional disk you need to add it, and you need to redistribute the data.
Got it, sir. Thank you.
Yeah. Let me click this one. So Snowflake architecture, it's an hybrid model. Snowflake architecture is a hybrid of traditional share disk and share nothing database architectures. Means Snowflake, it will this architecture is like a combination of both share disk and share nothing architecture, right? It will use the advantages of the both share disk and share nothing architectures. It will ignore or eliminate the disadvantages of both share disk and share nothing architectures. How we will see. Similar to the share disk architecture, Snowflake uses the central data. Snowflake uses the central data. Snowflake is the central data. As we discussed, share disk architecture is a central data repository, right? Similarly, Snowflake uses the similar to the share disk architecture. Snowflake is the central data repository for the persisted data that is accessible from all compute nodes in the platform, right? So here Snowflake is also a kind of some central data repository, so that whatever the advantages comes from the share disk architecture are applicable in case of a Snowflake architecture. Similar to the share nothing architecture, similar to the share nothing architecture, nothing architecture, Snowflake processes the queries using the MPP, massively parallel processing compute clusters, where each node in the cluster stores a portion of the data, entire data set locally. Means similar to the share nothing architecture, Snowflake uses the queries using the MPP, massively parallel processing, right? In case of a share nothing, independent node connected to the independent disk storage, right? Independent disk storage, so that there is no bottleneck and independently connected, and that's why we can get the massively parallel processing, right? That's why here we will get the parallel processing of the data, right? How we will see. This approach offers the data management simplicity of a shared disk architecture. As this Snowflake architecture is the central data repository, it will data management is simple because there is no data partitioning in case of in case of shared disk architecture. Similar to shared disk architecture, data management is a very simple here. But with the help of performance and scale out benefits like a share nothing architecture. The main difference here it is, let me open a paint. In case of a share disk, this is the share disk, right? All the nodes are connected to the common network. Whereas in case of a share nothing, each connected to the separate disk, so that there is no common network, right? Now, how Snowflake it is? It is a combination of both. How? I will show you. Similar to the share disk search, it's having the central data repository, and there is a kind of some cluster is available. These cluster having the different nodes, this cluster can connect to the this central data repository, right? In case of a share nothing architecture, each node connect to the portion of the disk, right? But in case of a Snowflake, each node connect to the entire data set, because the data stored in a central data repository. Clear? So that we are getting the shared disk architecture advantage using the central data repository. We are getting the massively parallel processing like a share nothing architecture. That's why there is no drawback of scaling limitation, right? We can add n number of cluster nodes because there is no bottleneck here. Similarly, we can add n number of nodes because we don't want to create the or add the portion of the disk storage, but because it is a central data repository, it's directly connected to the central data repository, right? Hope you are clear. Any doubts you can ask me. Oh, it's coming. So this is the Snowflake architecture. There are three layers are available, right? One is on a database storage layer, another one is a query processing layer, third one is a cloud storage layer. In case of a data storage layer, the data is going to store. Whenever we are trying to load the data into Snowflake, that data is going to store into this storage layer. Right? Into this data storage layer. Right? We'll discuss each one by one. Query processing layer. Here, here we can see there is it's a kind of node. Virtual warehouse is one node. There are the multiple nodes we can have in this processing layer. Right? In a cloud service layer, we have the different options. We'll discuss one by one. First one is the data storage layer. Snowflake uses the following cloud platforms to store the data. As we discussed during the demo and in other session as well, Snowflake is a cloud data warehouse which sits on any one of the three cloud platforms such as an AWS, Azure and Google Cloud Platform. As shown here, Snowflake uses the following cloud platform to store the data. One is an AWS. AWS in the sense, AWS is an Amazon Web Service which is a cloud platform, and inside that one there are the various services are available. Out of all, S3 is a one service which is used to store the data. Right? In AWS there is a service called as an S3. S3 is used to store the data. Means in case of a Snowflake, whenever we are trying to load the data into Snowflake, that data goes stored into the data storage layer of AWS. If you consider AWS is a cloud platform, while creating the Snowflake account, if you consider AWS is your cloud platform, whatever the data you are storing into Snowflake, that go and sit into the AWS. In a AWS, there is a service called S3. Inside S3, there are the buckets are there. Right? Inside S3, there is a bucket are there. We will have the around 2 to 3 AWS sessions to understand how backend will work. Right? Similarly, if it is an Azure, similar to the AWS S3 bucket, there is Azure blobs are there. We can call again buckets as well, right? If you consider Azure your cloud platform while creating the Snowflake account, the data, whatever you are storing into Snowflake, that is go and store into the Azure blobs. Similarly, Google. If you consider Google is your cloud platform, there is a GCP storage are there is a service where our data is going to store into this GCP storage service, right? When data loaded into Snowflake, Snowflake reorganize the data into internally optimized, compressed and columnar format. Let's say, for example, I have the data maybe on my local system, or maybe in some cloud, or maybe in some database. I am trying to load data into Snowflake. That data is going to reorganize and internally optimized, compressed and columnar format. Means it will optimize the data, it will compress the data. Compression in the sense it is going to decrease the size so that the storage charges will be less. Let's assume I have the 1 TB of data. After compression, it is to be 500 MB, right? So that the charges will be less and I will get the more space. And it will go store into the columnar format. We'll see what is columnar format. Elasticity. Storage is separated from compute layer. This allows the independent scaling of storage size and compute resources. In a cloud, in a architecture, 3-layer architecture, we saw the data storage layer, we saw the compute layer. Both are independent. So that we can scale only storage if we want. We can scale only compute if we want. Means you can only increase the storage capacity by adding the more number of data. We can only increase the compute capacity to process our requirement by creating the more number of nodes, right? And both are independent. I said during our demo, in case of an AWS or other cloud data platforms, there is a concept called node. That node contains the compute as well as the storage. Both are not independent. There is a combination of compute and storage comes as a one node. But here, node and storage completely independent. Let's assume I have a let me open a paint here. let's assume I have the one node. This node having the let's say assume some 16 GB RAM and some 5 TB of storage. 5 TB of storage. So if you want to, for your requirement, you consider this node, and you are started operating. After some times the data storage of the 5 TB is completed, you want to increase your storage. In case of an AWS or other cloud data wareforms, you cannot. You need to take another node. You need to take the another node, right? You need to take the another node where you will get the actually for your, what is your requirement here? Your requirement is only storage. You want to increase only storage from 5 TB to 6 TB or 10 TB. I don't want this additional processing power, but you need to compromise. You need to take these compute resource also. But in case of a Snowflake, for example, if you consider in case of a Snowflake, there is no combination of storage and capacity, storage and compute. Both are completely independent. Compute and storage both completely independent. You can increase only compute if you want. You can increase only storage you want without depending on others. That's what here we are saying, right? Storage is separated from compute layer. This allows for independent. This allows for independent scaling of storage size and compute resources without affecting other, right? Next one is a micro partition. One optimization that Snowflake uses is micro partitions. This means that Snowflake will set many small partitions on the data, which are then column stored and encrypted, right? In case of a Snowflake, there is a concept called micro partitions. Whatever data we are storing into Snowflake, that is reorganized, in the sense it is going to partition the data into small partitions, which are called micro partitions. In many olden databases or data warehouse, partitioning is a manual. We need to create the partition of particular size, 500 MB, something like that. There is a fixed partition of size is a manual, need to be created by the user. But in case of a Snowflake, micro partition is an automatic. Automatically Snowflake will create the micro partitions under of variable size, not fixed length. There is a variable size. Size is from 50 to 500 MB. The size of the micro partition is 50 MB to 500 MB, right? Depending upon our data size, automatically it will create the variable micro partitions of different sizes between 50 to 500 MB. And the data, whatever the data is going to available, that is going to store into these micro partitions in the columnar format. We'll see, right? If you see, here I have the kind of some logical structure. Is there, right? Logical structure means I have one table where there are the 4 columns. Column names are type, name, country, date, and there are the 24 rows are there. Whenever you are trying to load this data into Snowflake, physically it will store like this. It will create the 4 micro partition. In this example, I am showing the 4 micro partitions in a real time. Depending upon the data size, it will create automatically the number of micro partitions, and the size of micro partitions will automatic, right? It's for our example I shown 4, that may be 2, that may be 10, right, depending upon our data size. In this example, I have shown with 4 micro partitions. There is a micro partition 1, micro partition 2, micro partition 3, micro partition 4. Micro partition will store the first 6 rows 1 to 6. The second micro partition stores the rows from 7 to 12 of 6 rows. Micro partition 3 stores from 13 to 18 of 6 rows. The last 6 rows of 19 to 24 are stored to the 4th micro partition. And here the data is not stored as it is in case of a logical structure, but it is stored in the form of blocks. Right? Each one having the blocks. I have the 4 columns, that's why I can see 4 blocks here. And also data stored in these blocks in the columnar format. If you consider, for example, if you take this one, what is the data? 2, 4, 3, 2, 3, 2. See here in this block 2, 4, 3, 2, 3, 2. The next 6 rows of type column will go to these micro partitions 3 to 4, 5 1 5. Similarly, other. Similarly, other. Like it will store into the columnar format. Now, what is the advantage of this columnar format? Let's say, for example, I will explain one simple one. Let us consider I am trying to execute the one query which is nothing but select star from table where date is equal to 11 by 2. Consider I want to get the all the records. I want to get the all the records where date is 11 by 2. Right? For example, if you see here, date is 11 by 2 in this one. For the 6 rows is there, 7, 8, 9, 10. For the up to 9 rows, 11 by 2 is there. There are the 9 rows we need to pull. If you see in this diagram, if you see in this diagram, if you see in this diagram, in which micro partition 11 by 2 is there? In this one, in this one, in this one. Here there is no 11 by 2. There is no 11 by 2. Now, now whenever you are executing query, select star from table where date is equal to 11 by 2. If it is not Snowflake, that need to scan all micro partitions, means it will scan all the data. It will scan all the data and it will pull that particular records. But in case of a Snowflake, there is a concept called pruning. There is a concept called pruning. Pruning in the sense, it will scan the micro partitions which contains that particular data. For example, 11 bit, there is no 11 bit in the fourth micro partition. That's why it will scan only these 3 micro partitions. The Snowflake will scan only these 3 micro partitions and then it will omit this scanning of this one, so that the performance will be improved. For example, consider there are the 1000 micro partitions. Out of 1000 micro partitions, there is only 3 micro partitions having this data. So while scanning, it will eliminate the scanning of 997 partitions. It will scan only 3 partitions. How the performances you can consider, right? I will tell you one example. If you take the one engineering college, I want to, there is a one guy came and he want to search for a guy called Sudhakar, right? If he does not know what branch Sudhakar is, which year Sudhakar is, he need to go and search in each and every classroom. If he know he is from certain CSC backgrounds, so that he need to search for only CSC blocks. And if he know he is a third year student, he need to directly go to the third year classroom. If he is belonging to the A section, directly he will go and search for A section and he will call for Sudhakar. Same way, the Snowflake knows whatever the data required, it is available in which micro partitions. It will directly go and scan those micro partitions and it will pull the data, right? If you know Sudhakar is from CSC background, you don't want to go to the search for the triple background or mechanical background or civil related classrooms, right? Directly you can go and ask for the where is the CSC department, I need to go there. You don't want to go to the triple department, you don't want to go to the mechanical block or civil block. Similarly, it will ignore all these 997 blocks, 997 partitions, because the 11 by 2 data is available only 3 micro partitions. Same way. Then how it will know? That is concept called as a metadata. That we will discuss in detail during the metadata session. How it will know where my data is exactly available in which micro partitions, I need to eliminate for scanning, which is nothing but pruning. That we'll discuss in detail, right? As of now, the data is going to store into the micro partitions. The micro partitions will be created automatically by the Snowflake, which are of a variable size length between the 50 to 500 MB before compression, and the data is going to store in these micro partitions in the columnar block format, and data is encrypted and compressed. Clear? Any doubts? Okay, if clear, we'll go to the next layer. As of now, out of 3 layers, we finished the data storage layer. Now we'll jump into the another layer called compute layer. The compute layer, also called as a warehouse layer or query processing layer. This layer also called as a warehouse layer or query processing layer. Virtual warehouse is an MPP, massively parallel processing compute cluster composed of multiple compute nodes allocated by the Snowflake from the cloud provider. What is a virtual warehouse? What is a warehouse here? Warehouse is an MPP compute cluster. Right? MPP, nothing but massively parallel processing compute cluster. Compute, nothing but our CPU, which contains the CPU and RAM. Cluster, nothing but group of nodes. It's composed of multiple compute nodes. Cluster, cluster, nothing but compute nodes, multiple compute nodes. Cluster, nothing but multiple compute nodes. From where we will get these nodes? From where we will get this? Allocated by the Snowflake. For the Snowflake, where we will get? From the cloud provider. Clear? Whenever you are trying to create the Snowflake account, you choose some particular cloud platform. From that cloud provider, there is a nodes are available, a group of compute nodes, right, which are of MPP compute, massively parallel processing compute nodes are nothing but warehouses. Simple. For example, let me clear all this. For example, if I am considering my AWS is my cloud platform, right? In case of an AWS, for the storage service called an S3. In similarly, for the compute, there is a service called an EC2. Is nothing but Elastic Compute Cloud. This is another service which will having the nodes. EC2 will provide the nodes. So these nodes provided by the AWS cloud provider to the Snowflake. So these EC2 instances are nothing but my MPP compute cluster composed of multiple compute nodes. Clear? So what is meant by my virtual warehouse? Virtual warehouse is nothing but MPP compute cluster, MPP compute cluster composed of multiple compute nodes which are allocated by the Snowflake from my cloud provider. If you are considering AWS, it will provide from the AWS nodes. If you are considering the Microsoft Azure, while getting the Snowflake account, the nodes come from Azure. If you are considering Google Cloud Platform, the nodes come from the Google. A warehouse provides the required resources such as CPU, memory, and some temporary storage to perform the various operations in the Snowflake. Right? This warehouse is nothing but my compute cluster from cloud provider. What it contains? It contains the resources such as a CPU, memory, and some temporary storage. I have highlighted this thing. Why? Because this temporary storage is very, very important. During our catch class, we'll understand why I have highlighted over here. What warehouse contains? It contains the CPU, memory, and some temporary storage to perform the various operations. What are the various operations? To load the data, to unload the data, to process the data, to execute my query, to run my task. We need a kind of some compute power, which is nothing but CPU and memory. Right? Warehouse can be auto suspended and auto resumed. Right? We'll discuss. We can scale up or down. Okay. Before that, let me go back to my Snowflake account. I'm trying to log in into my Snowflake account. Username is an SDK. So logged into my Snowflake account. If I go down, there is a called compute. Here you can see the option called warehouses. Right? Click on warehouses. By default, there are some warehouses are there. Right? All are suspended now. Right? Now, the warehouse is having the CPU, memory, and some temporary storage. The warehouse in a two modes. One is in a running mode, another one is a suspended mode. We have a separate session for warehouses. As of now, I will give the high level idea. The warehouses can be in a running mode or suspended mode. When it is in a running mode, it will be chargeable. It will be chargeable. When it is in suspended mode, it is not chargeable. It is not chargeable. So that's why if you see here what it's saying, warehouses can be auto suspended and auto resumed, right? I'm not clear why it is getting. So auto suspend, auto resume. For example, if I am creating the, I have the one warehouse which is computed under WH. This is I am going to using to load my data. I have started loading the data. It may take some time. After loading the data, if my warehouse is in running mode, whenever it is trying to load the data, it should be in running mode. My warehouse should be in a running mode. Then only it will try to load the data. Means to load the data, I need some compute power that comes from this computer, the computer under WH warehouse. So after completion of my data loading, if my warehouse is still in running mode, it will be chargeable. So that I want to suspend that one. I want to suspend that particular warehouse. One way is you can go on manually, you can suspend. Another way is auto suspend. When you want to manually suspend, you need to sit in front of the system and you need to check for every time the data is loaded is completed or not. The data loading is completed or not. You are executing one query, that query is completed or not. That is a manual way. Instead, there is an option called auto suspend. You need to keep some window. You need to keep some window. For example, let's say give 5 minutes. If 5 minutes my warehouse is idle.
Can you blow slowly?
Yeah. That warehouse can be auto suspend or we can manually suspend. When warehouse is running, that is a chargeable. During our Snowflake pricing session, we'll understand how it is charged. Right? What are the various charges are available, how it is charged during the pricing session we'll discuss. Now, for example, if I'm executing one query where I'm trying to load the data. After during the loading, I need my warehouse should be in a running mode. My warehouse should be running mode so that there is a charges are applicable. After completion of loading, my warehouse should be suspended because if it is in a running, unless only there is a charges are applicable. Whether you are utilizing or not, if my warehouse is running, that is a chargeable. So one way you need to manually turn off or suspend my warehouse. To manual suspension, you need to sit in front of the system. You need to check whether my query is completed or not, data loading completed or not, and then you need to turn off manually. Instead, there is an option called auto suspend. Automatically suspend my warehouse when if it is idle for particular time. It is monitoring whether the warehouse is doing something or not. If it is an ideal for particular window, if I keep 5 minutes of window, means if my warehouse is idle for 5 minutes, it will automatically suspend so that there are no charges. Clear? Similarly, whenever I want to again execute another query or I want to load the data, one way is I need to manually turn on my warehouse. Means I need to resume my warehouse. Again, manually turning on it's a difficult. That's why it will automatically resume option is available. Means if you are executing some query, automatically it will turn on. After completion of my query, if within a 5 minutes, if there is no another request of there is no load, automatically it will turn off. That's why the Snowflake is offering auto suspend and auto resume. Right? Let me try to create the one warehouse. Again, we'll create in another session. Let me give the kind of some test under warehouse name, right? And Snowflake is offering warehouses like our t-shirt sizes, right? We can see extra small, small, medium, large, XL, 2XL, TX, 3XL, 4XL, 5XL, 6XL. During the warehouse session, we'll discuss what are these sizes and all. Right? For now, I am considering the extra small. If you expand this advanced option, you can see auto resume or auto suspend. Auto resume in the sense you are trying to execute the command. If you are trying to execute the one command. Yesterday, we saw like creating select star from particular customer table. Whenever you are executing that command, during that time, if my warehouse is already in suspended mode, it will automatically resume to running mode if you select this option. If you are not select, you need to manually turn on your warehouse and then you need to execute your query. Right? Next one is an auto suspend. For example, if you select the auto suspend, you need to keep some window. For example, I give the 5 minutes of inactivity. Means my warehouse is running and there is no activity assigned to that particular warehouse for 5 minutes, it will automatically suspend to save our money, to save our credits, to save the price. That is the concept of called auto suspend and auto resume. Next one is it will support the scale up down and scale out in warehouse, right? Now what is meant by scale up down and scale out in, right? Let me go back to the paint. So mainly we have two types of scalings. Horizontal scaling, right? And vertical scaling, right? In case of an horizontal scaling, right? In case of an horizontal, if you what we said, scale up down or scale out in, right? Scale out or in comes under scale out or in comes under my horizontal scaling. In case of a vertical scaling, it comes under scale up or down. Scale up or down. What does it mean? Scale out or in means scale out or means this is comes under auto scaling, right? As we said that the different sizes are available in our Snowflake. Different sizes of what's extra small, small, medium, large, right? XL, 2XL, 3XL, and so on, right? We have the different sizes are available, right? And also we have an option called multi-cluster. Multi-cluster in the sense a cluster can have the 1 to 10 nodes, 1 to 10 nodes, right? While creating our Snowflake, while creating the virtual warehouse, you can select the first size, right? Let me go to my Snowflake account. You need to select the size, which size you want, extra small, small, medium, and so on. For example, I select the small. If you go down, there is an option called multi-cluster warehouse. If you select this one, you can mention kind of what is the minimum cluster size, what is the maximum cluster size. For example, I can keep up to 10, right? This policy and all we'll discuss later, right? We can keep a minimum 1, maximum 10, minimum 1, maximum 10. So this is a comes under multi-cluster. Means if I select this one, in this warehouse we can have up to 10 small size warehouse nodes. We can have up to 10 small size warehouse, right? 10 small size warehouses from 1 to 10, right? Initially it will start with 1. Initially it will start with one cluster. Initially it will start with one cluster. If load goes on increasing, it will automatically add more number of clusters up to 10. That is called auto scaling. Now now if in this case I have created the one small size of multi-cluster of 1 to 10, right? Scale out in the sense scale out in the sense increasing the same small size, increasing same small size clusters from 1 to 2, 2 to 3, 3 to 4, 4 to 5. This is nothing but scale out, right? And scale in. Scale in means decreasing same small size clusters from whatever the maximum is during that particular time. If we consider 5, 5 to 4, 4 to 3, 3 to 2, 2 to 1, right? Scale out means increasing the same size warehouses from 1 to what is the maximum size we have provided. And scale in means decreasing the same size clusters from maximum size to minimum size. And what about the vertical scaling? Vertical scaling in the sense changing the size of the warehouse from, and we have again here two options. One is on a scale up, right? Scale up in the sense changing the size from small to medium, right? Medium to large, large to extra large, like vertically scaling. Vertically scaling means small to medium, medium to large, large to extra large, and so on. Scale down. Scale down in the sense decreasing the size of the existing warehouse from extra small to large, extra large to large, large to medium, medium to small, small to extra small. This is called a vertical scaling. Vertical scaling having the scale up or scale down. Scale up is nothing but increasing the size of an existing warehouse to the next upper level. Scale down is nothing but decreasing the size of the warehouse, existing warehouse to the next lower level. Similarly, horizontal scaling is nothing but scale out or scale in. Scale out is nothing but increasing the same size of warehouse in the multi-cluster from minimum size to the maximum size step by step. And scale in is nothing but decreasing the same size of a cluster from maximum size cluster to the minimum size of a same cluster size. And this is an automatic. This is an automatic auto scaling. This is not automatic. To do automatic, we need to do kind of some techniques. Clear? I don't know why I'm getting this white background here. That's why every time I'm going to reopen this one. So we can have a scale up and scale down, scale out and scale in this virtual warehouses. Each virtual warehouse is an independent compute cluster that does not share compute resources with other virtual warehouses. So we already discussed, right? Each warehouse is an independent. Whatever the resources it contains, that CPU, memory, or temporary storage, will not share with any other cluster node. That's why, as a result, each virtual warehouse has no impact on the performance of other virtual warehouse. The performance, in fact, does not depending upon other warehouse, right? Unlike a shared disk or shared nothing architecture. So that is about the compute service. The compute service also called as muzzle of the system. Muzzle of the system. Next one is a cloud service layer. All the activities such as authentication, security, metadata management of the loaded data, and the query optimizer that coordinate across the Snowflake happens in this layer. Authentication. Whenever you are trying to log into your application, it need to authenticate. Whenever you are connecting to the other third-party applications, it need to be authenticate. And also security. You are loading the data into Snowflake, that need to be taken security kind of view. And there is a concept called the metadata. We'll discuss in detail later for that metadata management. And the query optimizer. All these things will be taken care in this cloud service layer. This service layer also called the brain of the system. This layer is called the brain of the Snowflake. This also called a global service layer. Global service layer. The service layer enables the SQL client interface for DDL and DML like operations on data. For example, in a previous session, we have executed a command called Snowflake star select star from customer table. Whenever you are executing that query is an SQL client. That client will connect it to this layer. From there, it will go to the particular whether it is required to connect to the warehouse layer or data storage layer to pull the data. Right? It is a kind of some SQL client interface. Okay. Like other layer, this layer can also be independently scalable. Means, for example, you are executing one SQL query that connected to this interface. if there are the more number of queries executing by different users to the same Snowflake account, thousands of queries executed, so that automatically it will scale to match the requirement to handle that particular load. So that it will automatically independently scalable, right? These are the Snowflake architectures of 3 layers. Now, what are the supported regions in Snowflake, right? This diagram already we saw in our previous session as well. Like these are the supported regions. For example, if you see the yellowish one is in AWS, reddish one is on a Google Cloud Platform. This blue one is on Azure Cloud Platform. If you see across the globe, these are the supported regions, right? For example, in case of India, we see we have a support for the AWS as well as in Azure only, right? For the AWS, it is in Mumbai. For the Azure, it is in Pune, right? Any doubts here? If you go here, here we can see these are the supported regions, supported cloud regions for the Snowflake, and the same diagram whatever I shown here. And if you go a bit down in North and South America, these are the some commercial regions, and as well as the kind of some government supported regions are there. US regions supporting for the public sector, loads. These are the dedicated loads for this particular US government. And similarly, if you go down for the Asia Pacific, let me go a bit down. Asia Pacific and China. If you see here, here we can see the from India there are the two available. One for the AWS, another one is this is Azure. For the AWS one, AP South one. For the Azure, they named as Central India. If you go down bit for the AWS in Asia Pacific, we can see in India there is a region in Mumbai that is supporting for the Snowflake. And for coming to the Azure in India, there is a region for the Azure in Pune, that's they name called as Central India, is supporting. And if you go to the Google is does not supporting any region from India for the Snowflake. This is about the Snowflake architecture. If you have any doubts, you can ask me.
Sir will share this PDFs for us, this PPTs.
Yeah, I will share by converting into some PPT, PDF, and I will share, no problem.
Sure, sir.
Yeah.
Sir, in this shared one, go to that
Yeah.
PPT, na, sir?
Yeah.
The second one. Third one, sorry, third one. Third one. Can you explain this third point once?
Here,
Third. Yes.
this
Third
one.
one. Yes.
Yeah, similar to share nothing architecture, right? What is the main motto of share nothing architecture? Share nothing architecture will provide the massively parallel processing. In case of a share nothing architecture, all are independently connected. That's why the data is not traveling over to the common network. There is no bottleneck. That's why all are parallel connected. Each node connected to the separate disk, and each combination is in parallel. That massively parallel processing compute cluster is nothing but share nothing. Similar to the share nothing architecture, Snowflake also offering same MPP compute clusters. Means in case of for example, if you see here, this warehouse. Let me take a pen. Okay, pen is this virtual warehouse, right? This is parallelly connected to my data warehouse. This connected parallelly. There is no common point where the all are interconnected. These are the parallel clusters, massively parallel processing. That's what same as in a share nothing architecture saying. Clear?
Yes, sir. Thank you.
No problem. Any other doubts?
Sir, once go back for the slides.
Back or front?
Back. Once go for the slides.
Okay. Okay.
Fifth one, sir. Once go.
This one.
Not that one, sir. Seventh one, sir.
Okay.
What is the warehouse can auto suspend and resume, sir?
Yeah. Let me go to Paint. I will explain. Consider this is my warehouse. Okay. and there is some query executed. There is a find out some query executed, right? That query is allocated to my warehouse. This is my warehouse. This is my warehouse. That query allocated to that query allocated. Before that, let me explain another thing. For example, this is my warehouse. These having the two states. One is running or suspend, right? This warehouse has the two modes. One is in a running mode, another one is in a suspend mode, right? In case of a running mode, when my warehouse is running, it is a chargeable on second billing, means per second, chargeable per second, seconds. For each second, it is a chargeable. When it's suspend, no charges applicable, right? Let me go back to the Snowflake ones. Cancel. If you see, all are suspended. All are suspended. Okay, there is no charges are applicable now. Now here I am going to, for example, I am going to give one query. I am going to execute one query here, right? Whenever that query is submitted to here, whenever that query is submitted here, if it is already suspended, it will not accept that query. It should be in running mode. To make from suspend to running mode, we have the two options. One is in a manually, we can go and turn on. Let me go back here. If you select this one, one minute, right? You can resume manually. You can resume it, right? So to perform that particular query, to execute that query, this should be in running mode. To make from suspend to running, you can resume manually by clicking on this one, right? Or another option called auto resume. What this auto resume means? Simply you go to your let me go back. If you go to simply you go to your worksheet, right? Let me go to worksheet of any worksheet. Right? Now, if you see still my warehouse in a suspend mode only, right? This blink, see, suspended, right? Now, if I try to execute, let me try to execute my query. Now, I execute, see here, it will be automatically turned on.
That one is
See?
running mode, am I right?
Started, right? That's what auto resumed. Clear about this auto resume? Hello?
Yes, sir.
Yeah. The next option called the auto suspend. Right? Now, if you see here, if you auto suspend options, again, when it is running mode, it is chargeable. Now, if you go back here, now my query execution completed. Now my query execution is completed. Still, my warehouse is turning on. My warehouse is turning on. Unnecessarily, there is a charges are applicable, right? If you want to turn off this one, you can go to again warehouses. Go see here, it's started. Now go here, select these options. You can suspend manually. Every time it's not possible. It's difficult. So there is option called an auto suspend. While creating the Snowflake account, there is an option called auto suspend. Under advanced option, there is an option called auto suspend. You need to give some time. For example, if I give the 5 minutes, means if my warehouse is inactive for 5 minutes, means now just now I have executed that command. It's completion of that query. and now my warehouse is inactive, means there is no load, there is no request to my warehouse. It is for idle for 5 minutes, it will automatically suspend. That is concept called auto suspend. Clear? So that
Yes, sir.
it go to the suspend mode, there is no additional charges are applicable. Clear?
Yes, sir. Yes. Thank you.
Yeah. Any other doubts? Okay, if no doubt, that's all for today. Thank you. Thank you guys. Bye.